Hi, and welcome to this part 3 of our jigs and fixtures video. Today we're going to be looking at work holding. Very important that the part be held properly in the jig or the fixture. We're going to be looking at part positioning. So we're going to be looking at stops. Now stops and position go together. So we're going to be looking at stops, and we're also going to be looking at positioning a part in space, and that's crucial as well. And we're also going to look at tolerance. Tolerance is two ways. We're going to be looking at what we have to do with our jig to get the tolerances on the part that we want to get, and we're going to look at the tolerances that I have to apply to the jig to make things as simple and as inexpensive as possible. But we can't get into any of that before we familiarize, oh that's a big word for a Frenchman, ourselves with the part. Now we already know what the outside contour of the part is. We've already produced the blanks, but we didn't define anything as far as what holes needed to be produced and what surfaces needed to be milled. So let's head over to the whiteboard and take a look at that. Here's our part, and we recognize the original contour, but there's a lot of add-ons here. And what's new? Well, I have an angular surface here that wasn't there at the start. The client decided to add that on after the fact, and that, well, is good for me for two reasons. Ka-ching, I'm going to make more money. And secondly, well, it gives me an excuse to produce a milling fixture. So, I almost didn't get that one out. So milling fixture. So that's good here. And the fixture we're going to use here is really the most basic and widely used fixture in the home machine shop, and that is a vice jaw fixture. So we'll be doing that to produce this angular surface. And then I have 1, 2, and 3 holes. All 3 holes are 1/4 inch, but they're not the same. The diameters are, and they all have a diameter of 1/4 inch plus or minus 5. Remember that the dimensions with 2 decimal points, 2 numbers after the decimal point, is plus or minus 5, and the ones with 3, well, it's plus or minus 1. So here we have a first hole to produce that's plus or minus 5 from the 2 references. And then we have a second one that's plus or minus 1 from that first hole. And this is very important. They don't reference both back to the references. So once I produce this hole, I'm going to have to indicate that hole and make it my new datum, and then move on to do the second hole. It's important to operate in that fashion. I mean, they put tolerances here, it's for a reason. It's because that's what they want. And for those 2 holes, we're going to be producing a plate jig. At least that was the plan. But now that I look at the plate jig, just sits on top of the part, and the part lies on the drill press table. And that's great for parts that have a large primary surface. It's a stable part. And this is, but it's quite small, so it may be a little unstable or a little difficult to hold. So, seeing as it's small, well, we might use what could be called a modified plate jigger, and that is a table jig. And a table jig is a plate jig that's mounted on 4 legs, so it raises it up, and it permits me to give it a little more oomph. But that means that I turn the table jig over, I mount my part into the table jig, and then I flop it back onto the table on its legs, and then I can drill. That means that we're going to have to use a work holding device here to really counteract the force that we're going to be applying on the part during the drilling operation. So that'll be interesting there. And this other hole here, this third one, it's also 1/4 inch, but it's not oriented in relationship to the primary surface perpendicular. No, it's perpendicular to the tertiary surface. And that is the least stable of all the surfaces. The main 3 surfaces, not these angles, obviously. So, what am I going to use here? Well, I'm going to use an angle plate jig. And an angle plate jig just raises the part up perpendicular to the table, giving me access, in this case, to the tertiary surface. And it is going to be solidly clamped and positioned in that angle plate jig. So that's what we'll be using for here, but be careful. 0.25 from the bottom, 0.25 from the back side. You have to remember what your references are. And for the part, my reference was down here for the outside dimensions, but for the holes, it's up here. And in this case, it's down here. It's not this side, it's that side in relationship to this layout. So it's important to remember. And why am I saying that? Because the part is 5/8 of an inch. And well, the hole is 1/4 from the edge. So that means I'm going to have 1/8 of meat, 1/8 of 1/2 of the hole, 1/8 of 1/2, and that hole is not on the center line. Be wary. Holes aren't always on the center line, even if in the sketch they look like they are. So for that, an angle plate jig. So we're going to start now and move on to our 4 main subjects of the day. And the first one was work holding devices. Okay, work holding device. Well, the whole jig or fixture is a work holding device. So what am I talking about? I'm talking about how we apply pressure onto the part to hold it up against its stops, to immobilize it in space and counteract the forces applied by the machining operation. And what can that be? Well, the best example here that we can relate to easily is a machine vise or a milling machine vise. When we set up a part in the vise, the movable jaw applies a large amount of force on the part and pushes it up against its stops. And the stop in the case of a milling machine vise is the fixed jaw. So the movable jaw would be the work holding device in this case. It's the one that's applying the pressure. And that's a good example also because it gives us the notion of immobilizing something in space and counteracting the forces. When we put a part in the vise and we squeeze it down tight, well, it doesn't move anymore. It counteracts the forces applied by the milling machine, and it fixes it, it immobilizes it in space. So it does the 2 things we want it to do. What it doesn't do, and what work holding devices shouldn't do, is locate the part. And well, the vise doesn't do that because in 2 of the 3 planes, the vise doesn't align anything. So that's a good example. Now, what could work holding devices be other than a milling machine vise? Well, it could be a strap clamp, or it could be a finger clamp, or it could be a cam that applies pressure on the part, locking it into place. And that's an advantage with cams. They're usually auto-locking. So those types of things. But it could also just be a thumb screw or a set screw. It doesn't have to be that complicated. But you still want to follow those basic rules. So let's look at a first example, really the simplest one. It's a plate jig. We'll head to the whiteboard and take a look and see that this type of jig, well, breaks all the rules. It's a rebel jig because the work holding device pushes the part against the stops but doesn't really counteract any force. So let's go take a look at that. So here's our part. We're starting to get to know it. And well, I have my dimensions. It's an accurate part. It's an accurate part because it has to be as accurate as what's shown here. Now, as a general rule, the part isn't really that accurate. I mean, the tolerance is ±5, except for this one here. So this will be ±1, but the position of that first hole is related to the top corner here is ±5. So the first hole is not positioned accurately, but the second hole is, and it's positioned accurately from the first hole. That's important. We'll talk about that later. But this is 2 holes, and that's what I'm going to start with. I'm going to start by producing a jig to produce or to perform or to make those 2 holes. Now, you make a hole or you take it out? I don't know. So these 2 holes, great, we'll start with why. Why am I going to start with those 2 holes? There's no physical reason here to do it. It's more something that I think is just practical. And that is, I'm in the business to make money. Really, if you're in a home shop, you're not there to make money. You're there to have fun. But let's just go with that and say I want to make money. Let's say I had 1,000 of these parts to produce. This is the most accurate dimension that I'm going to have to make with, or attain with, a jig or a fixture. So, if I produce these two holes at the end of the project, well, this hole here that really I just can't miss. I mean, its position is plus or minus 5 thou. That's like driving a bus through town. I mean, you're going to go through town. It's hard to miss. And, well, this angle here is no more accurate than that one, and that means that it's plus or minus 5 as well. So there's nothing really accurate here. If I do this, and then do this, and then do these, well, I've got myself possibly into trouble. If I do these two holes on all my parts, and then I quality control them, and I discover that some of them are a little out, well, instead of moving on and doing all the other operations to those blocks that I know aren't good, well, I just turf them right away. And, well, that will save me time, because I won't have to do all the operations just to come back and say, well, I did all those for nothing because these 10 parts aren't good. So that's a good reason for starting with those two holes. Now, this will be the first jig, and it will be a plate jig. This will be the second jig. I'm going to produce a jig to produce this hole here, and its positioning isn't accurate. But I will be using a jig to do it, and it's going to be a angle plate jig. And at the very end, I'm going to produce a milling fixture to mill this last second add-on angle, the one that the client didn't want at the start. So, why that? Well, if I produce this hole as a second operation, that has a big advantage. And that is that this hole intersects with this angular surface. And the hole that intersects with an angle is going to deviate. So, if I don't want a deviant hole, well, I better not have that angle there. I'm going to drill straight through a perpendicular surface, or a surface that is perpendicular to the hole that I'm producing. That's why I'm doing this hole right now. And then, and only then, will I come and mill that final surface, and my part will be complete. So, we're going to be using, or producing, a plate jig for these two first holes. And we're going to use a plate jig that has locators or stops on it, obviously, because this part is going to have to be inserted into the jig and go where it's supposed to go. And we're going to be using 3 stops or locators here, and they're going to be pin locators. One at the very close to the edge of this surface here, and one close to the edge of that surface. One in the center of this surface here. Why 3? Well, it's a 3-2-1 rule. And if you're not fluent with isostatic positioning, well, you may not know the 1-2-3 rule for positioning parts in space. And it's crucial to know, and that can help you in all kinds of different operations, not just jigs and fixtures. So, if you have a few minutes and you want to learn about that isostatic positioning, here's a link to a video that can help with that. Now, 2 here, spaced out as far as possible. Why up here? Why not down there? This surface is longer because that angle isn't there yet. And I'm going to say right now, the further away that those 2 locator pins are, the more accurate it's going to be. Why? Well, let's say they're askew very slightly. One is a little lower than the other. If they're close together, a 1 thou offset can make several thousandths of an inch by the time I get to the end of the part. If I space them out as far as I can, well, I reduce that error. So, what does that mean? Why not here? Remember, you have to refer to your drawing. This first hole has no relation to this surface down here. It's dimension from this top corner. And that is all that is important here. That is the important corner for those 2 holes. And that means that this surface and this surface are the only ones that I can use to position it to produce those two holes. That is crucial. Where are your references? That's where your pins or stops have to go. So one here and one here, spaced out as far as possible, and one here right smack in the middle of this surface. Why one? Well, the 3-2-1 row. So one pin there. Well, that's fine and dandy. Why one and why in the middle? Well, why one? You'll see the video, but why in the middle? Because this surface may deviate as well. I mean, the pin can't be skewed because there's only one. But if the surface is out of axis slightly, let's say there's a little angle to it, it's not perpendicular to the other one perfectly, well, if I put the pin at the top here or at the bottom here, remember that angle's not there yet, so I can use the whole of that surface. If I put one down here, well, I'm going to have all the error from one corner to the other. Now, let's see. Let's say I had this surface and was out by 1/1000th of an inch top to bottom. If I put my pin at the top, the bottom's going to be out 1/1000th of an inch. If I put my pin at the bottom, the top is going to be out by 1/1000th of an inch. If I put it in the middle, the top is going to be out by 0.5 thousandths or 5/10,000ths of an inch, and the bottom is going to be out by 5/10,000ths of an inch. Plus on one side, minus on the other, depending which direction your out of perpendicularity is. So you see, that's important. Another important notion. On your tertiary surfaces, when you have your single stop or locator, you want it in the center, in the middle of the surface that you're going to locate. So I have two pins up here, one pin in the back. I have an order of operations. I'm going to be producing a plate jig, an angle plate jig, and a milling vise fixture for this one here. Now, I'm going to erase this, make a little sketch of a very basic plate jig, and then we'll check that out. So, you remember when in the last video I mentioned that I was having a little neuromotor problem there and I was shaking a lot? Well, here you have the proof. This is as good as I can sketch freehand, which is not really quite good. But we'll have to put up with it because it's the best I can do. And what do we have here? Well, we have the outline of our part in blue phantom lines. And we have in purple the lines pertain to the jig. So I have a plate and I have some blocks that might be milled right into the plate, I don't know yet, or they could be screwed on. And in those blocks, well, I have thumb screws. And those thumb screws are my work holding device. And I have 3 pins. These pins are my stops, but they're also my locators. So stops, supports, and, well, locators. They're all stops. So why the difference? I tend to use the term stop for locating pins or accessories that come into contact with a secondary or a tertiary surface on the part. They are not usually used to counteract much force, and they are really simply used to position the part in space. And well, we remember our isostatic positioning video for that. So that is what I would specifically call stops. So what are supports? Well, a support is a stop, and if I use 3 points of contact on a large primary surface, or any primary surface, well, I am using these to position the part, but I am also using them to counteract gravity, and more importantly, to counteract the force, in most cases, of whatever is applying the force on the part to hold it in place, or a work holding device. So these supports, and not all jigs have them. I mean, this one won't, it's just not accurate enough, and I'm not making enough parts to justify using them. But if I were producing many parts, well, those supports would lift the part off of the body of the jig to give room there for chips and dirt to accumulate without coming in contact with the part and the jig at this body at the same time. Now, if I look at what I have here, well, I can see that I already contradicted what I just said. And that is that, well, we're not going to be using supports on this one. I won't have those 3 points of contact on the primary surface. This is going to make the jig a lot easier and cheaper to produce, and since I'm not producing a lot of parts, well, that's just great. I'll have to, however, clean the jig more often while I'm using it. Okay, so I won't be using that, but I also mentioned that usually the force applied by the work holding device is going to be transmitted towards these supports. And in this case, I'm transmitting towards stops. And that's okay here, mainly because the force applied to hold the part is going to be very small. All I need here really is enough force to hold the part against those 3 pins. Because remember, with a plate jig, we have the part sitting on the drill press table, the jig over the part, and we drill through. That means that the most or the major part of that force is going to be transferred to the part. Your part's going to transfer it to the table, and well, there'll be little force in rotation here. And that's why these 2 thumb screws can be very light. If we look at this part and we ignore the jig that I'm trying to sketch out here, and we just focused on these 2 holes. Now, when comes the time to mill this angular surface on the part, these 2 holes will be finished and will be quite accurate. So I could use those 2 holes to position my part in space, both in X and Y, and then I would just need primary surface positioning to complete my 3-dimensional positioning of this surface. Now, if I use a locator, well, I'm using basically a stop that is inserted into a diameter. So a locator uses the internal diameters of holes to position parts accurately. And in this case, well, I'd use a round pin locator here, and I'd use a diamond head locator in this hole because I don't want to have opposing contact surfaces. And we'll be looking at that also when we design our milling machine vise fixture. So that'll be a fixture, not a jig. Now, before I let you go, I have received some comments or question, I don't know what it is really, but some people have noticed that on the part that I cut with the shaper in the last video, there's an odd or irregular or erratic, not erotic, line on the end of the part, just a little in from the edge of the end of the part that I was cutting. And where does that line come from, and what is it? Well, first thing, my shaper was set up to feed on the backstroke. And why is that important? Well, my shaper doesn't have a ram on it that lifts the tool at the end of the stroke. No, the tool lifts because it's on a pivot, and when it comes back, it strikes the end of the part, and it's free to lift, so it lifts up. But I was moving quite fast here. So when it comes back, it hits and bounces up, hits its limit and bounces back down. You can't really see it happen, it's too quick, but it does happen. And when it bounces back down, it hits the surface of the part on the crest of the cuspids, just where the high point of the, because when I come back, I'm feeding over at the same time. And when I hit those crests, well, it just smooshes them a little bit. It really doesn't do anything as far as the dimension of the part goes, but it does make that bizarre looking line there. And that will, all it is that, the tool that's falling back on the surface to be dragged along the part till we start the next cut. So, until we meet again in our next video, when we'll be really designing and probably start to produce this jig, this plate jig, well, have fun, be safe, and happy machining.
There you go.